Hello everyone again. Today we will speak about the custom function module. I think this is one of the most powerful modules in the SweepMe ecosystem, because this is the module where you can add functionalities to SweepMe that are not shipped with the ready-made modules, that are not coming with the instrument modules or with the things that are already implemented in SweepMe. This is the way to, let's say, to break out and add those components and those features that you need. During the session, I will also show you some kind of programming. If you have questions, please start immediately to write questions into the chat, raise your arm so that you can that we can directly discuss it in the meeting. Okay, so here you can see SweepMe. And I hope you're already somehow familiar with SweepMe, because this is, of course, already some advanced content where we expect that you know SweepMe and how to use it. And what you can see here is a sequencer that's almost empty. And what I added is a custom function module. And basically, just to understand the scope of or what you can do with custom function is you could basically write an entire software just with one module in SweepMe and use SweepMe to start it. Yeah. It means it is possible to add a script in custom function. It's a Python script at the end. You can run it, and you can run one program in just one module. And there you are very, very free what you do. But if you do this, you end up with writing individual code again. It means you have to maintain your own software again, and SweepMe would be just a layer to start your software. And from this point of view, our philosophy at SweepMe is that you use always as much as possible ready-made content like these instrument modules and other modules to create sequences. But whenever you have the feeling something is getting too complicated with it, it's sometimes necessary to switch into custom function, write your own script, and handle things as needed. Yeah, just to give you the philosophy how to use custom function and when. Also, you can create custom function modules in a way that they are very modular and that you can reuse them in other projects. So you can parameterize them so that for every different setup you use, you can maybe configure them and make sure that this is not a single function just for one setup, but maybe you can use it at many different setups. And this also gives you a lot of benefits if you do not have a single script or individual script that you have to maintain at one setup. But maybe you can use it at multiple setups. Imagine you have a database function to access your database. You could write it in a very general way so that you can use it at many setups. Okay, let's dive into the basics. And let's go to the custom function module. The custom function module looks like this. You have a section where you can select your custom function. You can always open a script and see how it looks like. And then it opens in your favorite editor. Here today I used the Notepad++. Additionally, you can always surf to the folder where your script is to see the folder structure. You can then add additional folders like additional libraries and so on. And here you also find the main.py, which is the main code that you write. Sometimes it's necessary to reload the function if you have made changes, especially if this affects the user interface, like the arguments and the variables. Also, it is possible to select one of the existing functions and make a copy, and you get a new function and you can directly start with using it. In these two other sections here of this module, you see the arguments. This is where you can get input or where you can define input that is handed over to the custom function script. And you see variables that are returned to SweepMe. At the end, the custom function module behaves like any other module, that connects to an instrument. You can hand over some parameters, it does something, and it returns values, and these values are handled like every other measurement value from an instrument. So SweepMe can then also plot these values. They are automatically saved to a file, and you can use these parameters to do further actions in your SweepMe sequence. Let's start with an example. You find examples that are coming with the installation of this module. And let's go to example minimal. You can see it's really minimal. There are no arguments. and there are no return values, but it's already a working script. Let's open this script. You can see here, these are 37 lines of code. And the main structure consists of a class that's called always main. You have here the possibility to add a description by using a docstring. I will also show you later a more sophisticated way to create a documentation. And then you see some static variables. At the end, you do not really need to know how this works in Python. It is just a variable that is directly defined under the class. And you can add here in the variables further information. And there you define your variables, units, and arguments. I will show you in the next step how to change this now. Furthermore, we have one function main, and this main function is called at every repetition in SweepMe. This means if we go back to the sequencer, we have here our custom function module, and we put it into a loop module. Give the loop module maybe a repetition of 5. Then the custom function will be 5 times called, and whenever it is called, the main function here in this script is triggered. Let me make this a little bit larger. I hope you can see the code quite well. And this section here below is actually just for testing the script. This part here is not really called by SweepMe. This is a typical Python convention. If you see this, if name is main, then this code is only run if you directly start this main.py file in a Python environment. This means you can start this script in your own Python environment and do tests independent from SweepMe. And this can be done with such a claim here. Then you create an object of your main class. You can maybe define arguments or hand them over to your script. And so you can run and test your script independently from SweepMe and use it also for other purposes, for example. This is just an example how to use it. But this is actually everything you need to create a custom function that is already loaded and working, but it doesn't do anything right now. Now we can start make a copy of this function, copy selected function, and let's say test web seminar. And I have when I open it, I have exactly the same function, but now it's my test web seminar function, and I can start writing some code. For example, I want to add a variable, so I use a string and say var1, variable 1, and var2. Now I can define variables. This could be, for example, a voltage, or it could be also an empty string to say we don't have anything. And if I now, I have to save this. If I reload the script, you can now see that SweepMe automatically parses the variables that are returned by our script. And additionally, I have now the chance to also define arguments. And these arguments are here a dictionary. This is indicated by these curly brackets in Python. And here you can define any key in a string, for example, input 1. And now you define a default value that is shown in the user interface. And depending on the type of this parameter, SweepMe chooses different types of how they are shown. Let's start with an integer and reload this. And you can see SweepMe creates an input 1 argument, and you can enter an integer value. So this is difficult for you to see, but if I type some letters, it will not be accepted. It only accepts integers. So I can add an integer here. And now the question is, how do I see this? How can I now see this in my script? Whenever you run a measurement, SweepMe hands over all input arguments to your main function via this keyword arguments object. And let's have a look how this looks like. I just need to return 2 values to not have an error. These 2 values need to correspond to variable in units. So I just return now 0 and 1 as a placeholder to return something to not have an error. And let's see what happens if I run this script with 1 repetition. And let's open the debug console. And what we can see here is, let me clear this and run it again. And you can see here arguments input 110. So let's compare this with our script. You can see the arguments are printed here. Keyword arguments are printed. And what you see is a dictionary where you have for each argument the selected value of the user input. So we can now do this even further and test string. Now I define a string. I go to my custom function, I reload it, I run it, and now you can see that we have a dictionary that is input 110 and input 2 test string. Okay, let's go back to our script. And now I could go here and say input 1 is my new parameter. I take my keyword arguments dictionary and, oops. Oh. And I can extract this by typing here the exact keyword. So I can remove this print, comment it out. And I can double this and say, for example, input 2, and here's input 2. So this is how I now retrieve the parameters that are selected by the user. And here at this step, I can do whatever I want, yeah? Do some calculations. And one thing I could do is, for example, input 1, input 2. They are now returned by SweepMe. Let's test this. We see no more print out in the debug. The script is running. So let's see whether this really worked. We add a monitor to our dashboard. And I go to my custom function module and I select my variables. And now you can see these variables already representing here in the user interface. Strings cannot be plotted. But if I go to my plot, I can also select the variable 1. And it's a small point here. But if I make the line width a little bit larger or the marker size, you can see that it printed 1 point at 10, which is the value that I handed over here. Okay, good. So these are really the basics. So the basic concept is you can define variable units and arguments. You have different types that you can define. And then you can do whatever you want with these inputs to calculate something. You can, for example, also hand over measurement data, send it to a server, and just return with a success code, for example, and log the success code. So there are many different things that you can do with this custom function. Let me go now to a more advanced example. And this is the called just example. And here in this example, you see that we have much more arguments. So this base example is a quite good option. Let me open the script again. You can see there's a much longer argument section. And here you can find all the typical input parameters or input types that you can use as arguments. And what we already had was an integer. Of course, you can also define a float. If you define a Boolean, then you see automatically a checkbox. You can also define a list. A list will be passed as a combo, a drop-down box where you can select between choice 1 and choice 2 here in this case. We can have a text, as I showed you. We can also have a path for a directory or for a file. This depends on how you define it. We use here a pathlib object. Pathlib is an included library that comes with Python and is a well-made library to define paths and handle paths. If you define a directory, it will give you the option to select a directory. If you define a file path, then you have the chance to select a file, and also depending here on the ending, you can then select files with this ending. Most important is maybe this tuple here. And this is the first one. And if you define a tuple, This is a placeholder in CustomFunction to choose any value from the system, from other modules, and hand over them. So this could be, for example, in this case now, the loop1 index. Let's go back to the script. So I handed over the loop1 index. And this I will explain later. Let's go to this main function, which is the main function, also the function that handles all the values. Again, you can see that we print the keyword arguments in this example. We extract the parameters from the dictionary, and then we can do some handling of the data and print out some data and return also test data. Okay, let's run this. Let me empty this. The sequencer is doing one repetition. I go for a run. And here you can see the printout of this example custom function. And what we can see here is the data that was handed over here as test data is 1 point, which means this is the value that comes from our loop module, and that can now change. For example, I can add here a 2 and run it again. And now you see that we have this print out 2 times. And our test data, here it is an array with 1. And here it is an array with 2. Okay. Let's go for a moment back to our test web seminar function that I just created. I open it again because it's a little bit less extra content, so it's better to concentrate on this. And let's add an input 3 and a tuple. Now I extract this and input 3. Let me show you what is input 3. Input 3. Okay, I reload the user interface. Now I can select the parameter and let me take the loop index. I run my script. Let me enter the debug and I run the script. And you can see input 3 is 1, then it is 2. And what you see, it is in these brackets, and this means it is a list or an array. And why is this an array? Custom function can be also used at different points in your sequencer. If you now hand over loop1, the loop module, and I run this, you can see that we now just get one output here. And this is because custom function is not part anymore of the loop module. It is now in a new branch. It is just called one time in this branch, but because loop1 values are handed over to custom function gets all the values since the last since the last call of custom function. This means whatever happened before, you get all the values, and this is why you get a list. It means from this list, you need to extract the parameters that you want to process. This mechanism is very important because imagine you want to measure in the first branch a solar cell with a full IV curve. Now you hand over current and voltage values to custom function. Of course, you want to have access to the entire IV curve, not just the last point. Because if you just want to process the last point, you could often also use a calc module. But with custom function, you get access to the entire history of the values that have been measured since the last call of custom function. Let me show this in a little bit more detail. I can add my sequence into a module that repeats everything again. Let me use here 3 repetitions and run it. And you can see, again, we get always 1, 2, 1, 2, 1, 2. So this is maybe not the best example. So let's go to custom function. And instead of taking loop1 index, we take the elapsed time. Because the elapsed time will change at every step. I will also make the debug a little bit larger. So now run this again. And now we can nicely see that there are additional values in. And Okay, this is just one value because time module is also part of the second branch. But what we can see is here the values are changing. Let me go to another value in the system that is maybe better to explain. Let me take a calc module. We can do here some simple calculation like sinus of the elapsed time and hand over this calculated time to this function. And now we can nicely see it. We can see that this parameter, the sinus of the time, changes with every step, and we get always the last two values that have been measured since custom function was called the last time. So once custom function is called, it gets the last two values. Then we go into a new loop. Loop one is measuring again, or calc is measuring or creating new data again. They are handed again over to custom function, and you can process them. If I would add custom function here at the bottom and rerun it, you can see that we get two nested lists. So where we have a list for each repetition of the values in this super list. But this gives you access to what happened in the history, and this is often necessary to evaluate your data. For example, you can make a very complex measurement. At the end, you run a script that takes all the data and makes a more complicated mapping or calculation. Okay. Now I will go back to custom function and to my example function. And I open the script. And what you have seen here are additional functions. And for all of you who already are in driver programming, you might know these functions like connect, disconnect, initialize, deinitialize, configure, unconfigure, and so on. And these are the semantic functions that we use in our driver structure to call different tasks for instruments at different steps in the measurement. And also custom function scripts can mirror this behavior, and you can add steps at different parts of a measurement flow. For example, in prepare run, prepare stop, you can do some GUI-based handling before the measurement even starts. In connect, disconnect, you can connect to instruments or can do some connections to a server. Then you have initialize, deinitialize, configure, unconfigure, and sign in, sign out functions. So this is very similar to the driver functions. We expand the supported functions depending on needs. And so let us know when further functions need to be supported. But you can find the documentation for this also in the driver programming in the wiki, and also in the sequencer procedure calls in the wiki when these functions are called. But the main function here is the one that is once getting the data and where you can do some calculations with the data you have. Okay, so then I come to a next step. This is about importing libraries. Typically, SweepMe comes with a bundle of Python libraries that are shipped with SweepMe, that are synchronized or that are in accordance with the Python version that we use. You can find these libraries when you go to help and info and go to credits. And let me move this here to the second screen. Oops. Once again, here it is. And and here you find libraries that we ship with Python, with SweepMe, that are not coming with Python itself. And these libraries, they can be immediately used in drivers, but also in your custom function script. So libraries like pandas for data handling. You find also things like NumPy and SciPy for data evaluation. You have these typical communication libraries like PySerial, PyVisa. And what is probably also very important is, of course, PySide2 is shipped. PySide2 is a library that handles that we use for the creation of our user interface. It is the binding to the Qt library. So PySide2 is also very important in custom functions to create own user interfaces and own user widgets. Okay, sometimes it could be that you have a function or a library, I mean, that you have a library that is maybe your own library that you wrote on your own, or you have found a library in the internet on PyPy that is not shipped with SweepMe. Then you can, of course, also use this in a custom function script. And the idea is that you add a folder to your example. Here in this example, there is no additional ship library. Let me have a look whether I find one that has a ship library. I think there was one that is called create animation. Let's click on this folder. And here you see a libs folder. And this libs folder comes with a library and a license file that describes how to use this. And these things can be used in, can be also used. Let me check OpenScript. Yeah, this was the image IO library. This is a library that helps you to use a lot of images and put them together into a GIF file. So this was a custom function where you can hand over images, take these images, append them, and then create an animation. And for this, we had to ship the image IO library with this custom function script. So it's now part in this libs folder. And to do this, we have here some lines with a folder manager. And they are also shown here in our example function, where you can, with 2 lines, you can import our folder manager, use add folder to path. And this means it adds the folder of the path where this script is in to the environment variables. And now Python will also search through these paths to find libraries and will find then the, for example, the image IO library. So this part is already part of the example. So actually you can directly start adding a lib folder to your custom function and add your own library. Here we also have a tool that is called Library Builder 2. This is a tool where you can, from a requirements file, define exactly those libraries that are needed to be shipped additionally to what SweepMe already ships. But this is, let's say, an own topic besides what we want to speak about today. You can find also further information in our wiki. Write us in the forum, for example, if you need more information about how to ship libraries with your custom function script. Okay, then the documentation. I wanted to show you how you can add a documentation. Let me go back to our example. When I want to see the documentation of a script, you can just click here on this question mark button next to your custom function. And there's a window that opens up and that explains how to use your custom function. But at the end, it depends on you whether you write the documentation. And if you want to have code that is reused by a lot of colleagues and understood by a lot of colleagues and co-workers, documentation is important. And this gives you the chance to make a documentation for your custom function script. Let me close this and open the script. You can see here a docstring. This is a typical convention in Python that you can add a triple quoted docstring, and this docstring is passed into this widget when you press this button. Here you can also use HTML. But the better way how to handle this now is using a markdown file. Markdown is a description file format that is easy to write, where you can structure things like headings, bullet points, and so on, and where it is not that difficult to write this HTML code. And for that, I also made an example this morning. I go to my test function. I click here on my question mark, and you can see test and the first bullet point. Let's close this. I go to my folder. And what you see besides the main.py, you can see a doc folder. And in this doc folder, there must be a description.md. I can open this description.md file, and you see it's a markdown file with a hashtag to create, for example, a heading, a dash to create a bullet point. You can also use, for example, asterisks to create numberings. And if I now go back to SweepMe and click on the dash you can see here that we have different bullet point types and structured documentation. Markdown is well understood by AI, so it also makes sense to, for example, write first documentation skeleton or the first draft with AI and then refine it on your own. There are also a lot of markdown converters, so you can really have a single file for the description. And I would recommend to do this because this will empty your file and you don't have such a long part here with unreadable HTML code in this section. Okay. Now, I wanted to go into this part to describe that you can reuse custom functions if they are well made in many purposes. And one thing I want to show you, yes, just let somebody in who's joining again. What I want to show you is that we also have some pre-shipped functions that you can reuse. And one of them is, for example, evaluation statistics. This is a function that can calculate mean, standard deviation, median, min, and max. So this is some statistic function that comes with custom function that you don't need to add on your own again. So one can work on this script, can use this script. So to do this, I will create a simple measurement. And I brought today here a simple sensor device. This has 8-9 different sensors on it, and we can use it to get some real world data. Let me start with a loop module and push this to infinity, also to set it up to run infinite. And then I use a delay module to slow down the measurement a bit. We have now values every 0.1 second, so 10 values per second. I add my logger, and the logger is the CalUP sensor that I have. I click find ports. This is only COM3 here. This makes it easy to find the right COM port. I click the retrieve button to see whether the sensor is connected. Now I put my custom function module into this branch so that it is active all the time when the measurement is running. I go to my custom function module and the evaluation statistics function is already selected. And now I can add or can see data that I can evaluate. And let's see what we want to see. Maybe we take the acceleration because this is something that I can easily control by shaking the sensor. To learn how to use this, you can of course then again see the description. So let me go to the plot and run this measurement. So you see the plot, and now I can shake the sensor, and I can here do some noise or some variation in the sensor signal, and I want to see the additional values. So I can add, first of all, I can add my sensor value. This is the X value. And now I can also take my mean value. And you can see the mean value is exactly on top of the data. So why is this the case? In this custom function, we can have the measurement between, we can define whether we want to append the data to all the previous data, or we want to evaluate each single data set on its own. Because each single data set is just 1 point, the mean value of 1 point is exactly the same value. This does not make much sense. So this only makes sense to append data. But sometimes you hand over a complete list and you want to operate these statistic functions on each single list. So then it's not good to use append, but here we use append. And let's run the measurement again. And now you can see that this orange value is on average on what we do here with this function. And we can, of course, also add other functions like min or max. And you can see that the min and the max value here, the green and the red curve, they're expanding the larger the values are. And this could be, for example, a nice function to plot min-max values here in in the monitor, and you can see with 2040 they are at the maximum, I think, what this analog digital converter can do. But if I start again, you can see the minimum maximum are some values that I can now step by step increase, and this is when I stop the measurement, I can now easily see what was the largest value ever I made in my measurement. So what I want to promote here is to write custom functions in a way that you can reuse them by adding a clever way of arguments, so that users that want to use the similar content in a way that they can configure it and do not have to write always a new function. By this, you only need to maintain one function, and then you can use it at many different setups. So it may often make sense to add arguments that allow users to configure such a function. Okay, so now I want to come to the next part of the seminar, which is about typical use cases. We have already seen some of them, so we can skip probably one of them. And the first use case is, for example, data evaluation. I think this is what we already did here. We hand over data to CustomFunction. We do some processing of the data. We get some new parameters that can be calculated. For example, you can hand over a transistor curve and do an evaluation of this transistor curve. And then you can, for example, calculate maybe a threshold voltage or the maximum transconductance, for example, of a curve. So this is typically data evaluation, where you need a Python script, which is difficult to handle this calculation with the calc module. The next thing that you can do with custom function scripts are control scripts. You can imagine that when we hand over some data to custom function and we get a return value, these are these return values, these variables, we can also take a module, add it here to to our event loop, to our branch. And now, for example, I use a source measuring unit. And this source measuring unit typically, or this module, has typically a section where you can define which value has to be varied and where does the value come from. And of course, here you can also use, for example, the median value of custom function, just as an example. So I don't want to go too much into the detail with programming now a control script, but the idea is maybe clear. You can hand over data to custom function, do something, and propose new set values for other modules. And here you can, of course, also propose multiple set values for multiple modules and control things. And this feature is, for example, used when we create control programs in SweepMe, for example, for controlling a deposition process in a vacuum chamber. There you often have multiple parameters that need to be considered, and then we really need to add an individual script that is controlling this process, and we can hand over new temperatures for the temperature controllers or new power for power supplies, or we can also return a state for a shutter in a vacuum chamber. So these control scripts are maybe not so important for people that work now in semiconductor device characterization, but everybody who is using SweepMe for processing samples, this is very helpful to create scripts that can control processes with this mechanism. Another way to use SweepMe or to use custom function module is also to create custom widgets. Let me show this. One custom function that you can immediately find as an example is, for example, this example GUI. And what you see here, once I selected this example GUI, a widget popped up. And this widget I can add somewhere into my dashboard. And now it is part of my dashboard. If I save my setting, this will be stored here and I can reuse it. And this is a function where I can hand over some values. Let me first remove things from my sequencer that don't make sense right now. Yeah. And I can hand over, for example, my acceleration in X, and I can hand over my acceleration in Y. And what I get as a return value is the value of my dial. Okay, let's start this script or this setting. And you can see that the dial value is 11. And I can change here the dial. And this changes the plot here. And I see the acceleration value of my sensor as X and Y in this widget. And why this is important? Basically, this allows you to add whatever widget to the dashboard with a very unique functionality. And this also maybe comes back to my point in the beginning. You can basically write an entire program just in a single custom function module in SweepMe and just use SweepMe to run your own program. You could basically put everything into one widget and let this widget fill the entire dashboard by removing all the other widgets. This is not the typical use case of SweepMe, but I just want to show you that you have a lot of freedom from just using the standard widgets and the standard modules until you do everything on your own. And in between, you typically find a solution where you can make use as much as possible from ready-made content, but then add all those things on your own. With this dial value, for example, I can hand it over again to an instrument, and I can create my custom control section in SweepMe for a certain machine, for example. And let me show you another widget. This is called GUI pass fail. This is also part of our of the pre-installed functions, so you can also use it as a template. And what this thing is doing, it is showing you a red or green signal whether you have a test that has passed or failed. And here you can hand over a value. So let's hand over a value. And with that, I can also show you another way how to hand over value to scripts, because if I open this, you can see that the state here is defined as a string. This means it is not this tuple where you can select a value, but this is a string. And if it is a string, SweepMe gives you the possibility to hand over a parameter syntax. Parameter syntax, you can find a parameter widget. Yep, this one. In this parameters widget that you get via the widgets menu, you can find parameters in the system. And today we want to show, for example, the rotation roll. This looks like a nice parameter. I can copy it. And what I get is here exactly that I can copy this parameter into a string field, into a text field. And SweepMe recognizes the curly brackets and knows, this is a parameter from the system. I have to replace it with the corresponding parameter, which is at the moment, for example, -37°. But if I just hand over -37° to a custom function, this would not work because our custom function expects, I can also show it here in the documentation, it expects a Boolean true, an integer 1, or a string which true or pass, and the corresponding false and fail values. So what we need to do is we have to first create something that returns a true. And the best thing to do this is to make here an inline comparison. And we say if the rotation is greater than 0, it is true. And if it is less than 0, it is false. And to evaluate such inline impressions, you have to add another curly brackets environment. So the entire parameter syntax in SweepMe works like this. SweepMe checks curly brackets. If the content inside the curly bracket is a parameter, it is replaced with the value. If it is not a parameter from the system, it is evaluated as Python code. So it first looks into the inner curly bracket. This is our parameter. This is replaced by the value. Then there is something like -37° is larger 0. This is false. And at the end, false is returned to the system. Let's run this code. And now you can see pass fail. I take the sensor and I can move, I roll it. And by changing the angle of how it is rolled, I can now change from pass to fail. So this is functionalities you can now modularly add to SweepMe by creating your own widgets. And let's have a look at this GUI pass fail widget. I open the script. And here a little bit more is needed. one thing you need is that you have this renew widget function. This renew widget function is also explained in more detail in the wiki of the custom function module. Felix also added a link to the chat where you can find this link to this wiki page and where you can find how to add, for example, such a renew widget function. And here it is explained how the GUI mode works and so on. But basically, the renew widget makes sure that you can hand over a widget to SweepMe, and SweepMe remembers this widget. And when this function is restored and reloaded, this function gets this old widget again. So you can always operate on exactly the same widget. So this is basically some standard code that you just need to add, and you do not need to do much more than this. The rest of adding an own widget is actually to write a widget in PySide2 style. PySide2 is the library that allows you to create Qt content, and Qt is the library to create our user interface. And so basically you create a widget, and this widget is not that long actually, to define the layout of this box. You can add then for different functions like to reset the label, to set a path, to set a fail and toggle state, for example. And here I use then style sheets to add a green background and so on. This first version of this widget I wrote with AI. Nowadays you can go to any LLM like ChatGPT or Claude or whatever you use right now. And you can tell, please write me a Qt widget where the import is from Qt widgets and from Qt core. So you should make sure that the imports are correctly like as done here. And then you get a widget. And this widget is basically independent from SweepMe. You could use it in any Python code. And the magic is then to make this binding to our custom function. And this is then here done in this renew widget where we define this widget, which is exactly this name here, as the widget to be loaded. And this will load the widget. The main difficult to add own widgets is about handling the different threads. So SweepMe is running in different threads. This means the user interface is running in one thread, and the user interface is running in one thread, and the measurement is running in one thread. The custom function is typically running in the measurement thread because you want directly access the data from the measurement and handle it. But the widgets, they run in the user interface, in the GUI thread. And for this, you need to use signals. Signals is a concept in programming that allow the software to decide on its own when it is processing the next step and putting it in the correct queue, in the correct order of the queue of the GUI thread. So what I did here, I added some signals, and yes, and where can I see it? Exactly. And what I do is here in my main code, which is in the measurement thread, I go to, I take a signal and I emit the signal. By emitting a signal, the widget can then decide on its own when the GUI thread is taking action again and is processing this thing. Especially for user interfaces, this is often not necessary that you immediately switch the state, but that the green state is switched in a couple of milliseconds. For the human, it still will switch to green at some point. And the same thing is here, that I emit the state. For example, I emit the pass signal and I emit the fail signal. You can define signals also in a way that you can hand over an argument, like true or false. But here I created single signals with no arguments that simply change the state. So this is a nice example also how to get signals into this concept and how to use this. Okay. But basically, custom function can then be also used to create your own input mask, for example. Of course, I would always recommend to use the formula module to create input masks, but if you have a very special input mask, you can, of course, also create it with custom function. And a last very often used use case for custom function is to have a database access. This means that people write a function, let's go back to our example, where they have many arguments, Each argument is a data set that they want to hand over to the database. And then they process the data in the script and send it to a server. More elegant is to write a binding to your database via, for example, a JSON script, a JSON string. This means you send one big string to your database, and in your database, the data is then handled and by your IT redirected to different database structures. And then you have one connector here in custom function where you have one single input, and you can create another custom function to just create this big string that contains all the data that you want to send into the database. By this, you can also separate again a little bit the logic, because then not always the database sending and the database data creation is in one script. So you can reuse, for example, the script to send the data to the database. And for each setup, you only have to change the script that compiles all the data into one container string. Okay, so these are really the typical use cases that custom function is used for. It is also possible to run the main function in different phases. Let me show you whether this is already here in this. No, it's not in the example right now, but let me go to the wiki. You have the chance to change the phase where the main function of the script is running. You can change it to different points in the procedure. And this is how it is possible to also create values in the apply phase, for example, of the measurement. Because in the standard, custom function runs at the end of a measurement point in the process phase. It means you have measured something, now you want to evaluate it or send it to the database. But sometimes you also want to run custom function scripts on set values that are then directly already handled as the next apply value. So you can change the phase in where this custom function script is running. This is described in the wiki. Okay. As a last point, I want to go into how to share scripts and how to handle scripts. One thing that we have just started is that we have moved our custom function scripts to GitHub. And this means if you go to our GitHub repository, SweepMe, you can also find it via our webpage. You can find here a repository that is called custom function scripts. At the moment, you find basically all these examples and functions that are already shipped with SweepMe or with the custom function module. We will in future add further functions that are not shipped anymore with the custom function module, and where each user can decide to add them to your installation or use them as an example. So we plan to add further functions like evaluation functions for solar cells or for transistors to make it easier to quickly add such evaluation functions, yeah, to SweepMe or to your measurement. Additionally, you can add on new functions on your own by use this copy selected function, as I did it here in the beginning. Let's go to test web seminar. If you open the script, you have the chance, if you go to folder, you can see there is a folder in the public SweepMe folder. This public SweepMe folder is typically here. I cannot click it because of this Teams meeting bar. But if I click it, I can find these custom functions in the public folder where also the drivers and the settings are stored. If I go to data modules, custom functions, I can find these functions here. You can basically copy them and transfer them to another setup. SweepMe also has a functionality now in the version manager where you can export import things. So you can export a bundle of all the contents on your SweepMe installation. And with this bundle file, you can go to another setup and import the bundle. And then all the drivers and contents that you have at one setup are transferred to another setup. And this will also move your custom functions that you wrote to another setup. There's further the possibility to define an environment variable. This is described in our forum in one of the posts. I have not have it right here right now, but you can also add an environment variable where you define a path from where custom functions are loaded. And in the new version 1.58 that is now in beta state and where we still add some new features, we have added a more convenient thing to add new paths for custom function via the options of SweepMe, where you can define it then in the path, but this is not still yet in this version that I use here. So this will make it more convenient to add your own repository and keep track about your custom functions and how to share them across different setups. In future, we plan also to have a similar system like this version manager for custom functions, so that you can download custom function scripts from a repository or from a server. But this is still a work in progress.